We've always believed Earth was the perfect planet, the ideal distance from the sun, a breathable atmosphere, stable conditions, the only home we've ever known. But what if that wasn't true? Recent discoveries suggest that some planets out there might not just be similar to Earth, they could actually be more habitable, more stable, more comfortable, more suited for life. Is Earth really the best the universe has to offer? Or is something even better waiting to be found? Before we begin, if you enjoy this content and want to see more, please consider liking and subscribing. It helps out a lot and lets us keep exploring the wonders of the universe together. Far beyond the stars we know, past the quiet flicker of Mars, beyond the churning cold of Neptune, there's a place so distant, so far removed from the familiar paths of our solar system, that the very idea of it feels like a dream whispered in a forgotten language. It's called Kepler-22b. Discovered in 2011 by NASA's Kepler Space Telescope, it lives in the constellation Cygnus, over 600 light-years from Earth. That distance, nearly 3.5 quadrillion miles, is almost meaningless to us. Our minds weren't made to comprehend such space. If you tried to drive there at highway speed, it would take you about 6.7 billion years. But space doesn't mind. It stretches endlessly, carrying its secrets slowly, silently, and without urgency. Kepler-22b orbits a star remarkably similar to our own, a G-type main sequence star, just slightly cooler and smaller than the Sun. In some ways, that alone gives this planet a sense of familiarity. It's not orbiting a chaotic red dwarf or a massive blue star prone to violent flares. Its sun is, by all appearances, calm, stable, like a heartbeat in the quiet of the void. And Kepler-22b orbits that star in what scientists call the habitable zone, the not too hot, not too cold Goldilocks region where liquid water could exist. That phrase, liquid water, might not sound all that impressive, but in the vast, frozen dark of the cosmos, water is a kind of magic. It's rare, it's precious. It's the difference between a world that can harbor life and one that can't. That's why Kepler-22b has captured imaginations across the globe. From a scientific perspective, it's a super-Earth, roughly 2.4 times the diameter of our planet. That's big, but not too big. It's still within the range where it might have a rocky surface. And if it doesn't, then it could be even stranger. A water world, entirely covered by ocean. No continents, no mountains, just waves upon waves upon waves. Can you imagine it? A world where the only landscape is seascape. If you could stand on some kind of floating platform and look around, you'd see nothing but the curvature of the horizon in every direction. No trees, no sand, no buildings, just the endless hush of a planetary ocean under a foreign sky. But even the sky might feel oddly familiar. Because Kepler-22b's star casts a light that isn't so different from our own. Maybe a little dimmer, a little cooler, but warm enough to illuminate the cloud tops, to scatter across the atmosphere, to paint the water in golds and silvers at dawn and dusk, if such things exist there. We don't know what the days feel like on Kepler-22b. We don't yet know how long they last, but we can guess. We know that it completes a full orbit of its star every 290 Earth days, just a bit less than our year. That orbit places it comfortably within the habitable zone, a perfect distance for potential life to thrive, or at the very least, for conditions to remain stable over long spans of time. But more than anything, Kepler-22b feels calm. Where Earth is defined by tectonic plates colliding, by continents shifting, by ice ages and wild storms and scorching deserts, Kepler-22b, if it is indeed an ocean planet, may have been spared much of that chaos. Without land masses, without mountains to stir the wind, without continents to heat and cool unevenly, the climate might be unimaginably smooth. Picture it, a world of perpetual balance. Winds so gentle they never scream. Clouds so slow they drift for days before changing shape. Rains so soft they barely make a sound on the endless sea. Of course, this is speculation. Beautiful speculation. But it's grounded in science. Based on its size, orbit, and host star, Kepler-22b is one of our most promising Earth-like candidates. And yet, it is also so utterly alien. This is not Earth's twin. It's something else. Something unfamiliar but strangely comforting. It offers a vision of a planet that doesn't fight itself. A world not torn by volcanoes, drought, or deforestation. A place that simply is. A place that waits in silence. If we could descend from the black silence of space and pass through the upper layers of Kepler-22b's atmosphere, we'd find ourselves immersed in something that feels like a living breath. The planet, larger than Earth, holds more tightly to its air. Gravity here is stronger, just enough to make everything feel heavier, slower, quieter, like moving through a deep dream. The sky begins to deepen. Thin, high-altitude clouds stretch like silk across the stratosphere, brushed flat by gentle winds that have been whispering the same rhythm for millennia. There are no violent storms here, no spinning hurricanes or crashing cold fronts, just patterns, slow and soft, weaving across the atmosphere in loops too large to measure. If the atmosphere has any haze or moisture, it diffuses the starlight into muted tones. Not quite the bright blue skies of Earth, more like a pale teal or a faint aquamarine, depending on the particles floating in the air. And the sunlight, filtered through this otherworldly lens, would scatter into pastels, yellows that melt into lavender, faint rose-colored clouds curling at the horizon. We keep descending. Now we reach the lower atmosphere. The air is denser here. It presses against the skin, heavy but comforting, like a warm blanket. The clouds become thicker, smoother, forming endless sheets that slide beneath us, unbroken. Occasionally there are breaks in the blanket, windows through which we glimpse the surface, dark, deep, and utterly still. Then, through one of these quiet gaps in the clouds, we see it in full. The ocean. It stretches without interruption, without coastline, without border. No island juts from its surface. No mountain pierces its depths. It is a single, unified sea, global, continuous, and hauntingly beautiful. But this is no ordinary water. The pressure from the planet's mass might make the surface of the ocean flatter, denser, and darker than anything we know. Light doesn't reflect as it does on Earth. It glows in smudges, like ink spilled on a black page. The waves, if they exist at all, are broad and slow-moving, rolling silently beneath a ceiling of clouds. There is no surf, no shore, and in this silence we can imagine what lies beneath. The upper layers of the ocean might be illuminated by the filtered light of the sun, dim, soft, but present. You might see soft beams of it, piercing the water in long shafts, dancing slightly with the current. But as you sink deeper, the light fades quickly. Soon you're in darkness, a velvet dark. Not the darkness of fear, but the kind that invites stillness, the kind that feels safe, as though the planet itself is tucking you in. There is no turbulence here, no sound of whales or crashing icebergs, only the sound of your own breathing, if you were here to hear it. In the depths, the pressure is immense. The ocean could be hundreds, even thousands, of kilometers deep. If Kepler-22b is truly a water world, its oceans may reach down through layers of exotic ice, compressed so tightly they begin to take on crystalline forms unknown to Earth. These high-pressure ices, Ice 7 perhaps, or even more exotic forms, could line the ocean's bottom like a foundation, forming a strange, solid seafloor that no tectonic plate ever moved. There are no earthquakes here, no volcanoes. The crust, if one exists, is far beneath this alien sea. Still deeper, you might find geothermal vents, not from volcanic activity, but from the faint residual heat of the planet's formation. Here, in these isolated pockets of warmth, life might begin to form. Not life as we know it, perhaps, but microbes that drift through mineral-rich plumes, feeding off chemical gradients in the dark. It's hard to say if life could really take root here, but the ingredients are not impossible. Liquid water. Stable temperatures, possibly a carbon cycle, maybe even an atmosphere rich in hydrogen or carbon dioxide, depending on how the planet formed. And even if there is no life at all, Kepler-22b still holds an eerie elegance. A planet that has moved in silent orbit for billions of years. An entire world with no footsteps, no birdsong, no war. Just water and wind, sky and sea, and above it all, the clouds. Endless sheets of vapor that form, stretch, and vanish over the ocean's face. If you watch them from above, it would look like slow breath. The planet inhales, then exhales, not in seconds, but in hours. Days. The weather doesn't crash here, it drifts. It's the kind of place where time feels irrelevant. There are no landmarks to mark the passage of days, no calendar of seasons. The temperature changes slowly, if at all. You wouldn't notice a difference from one month to the next. A storm might take an entire year to cross the planet, or perhaps there are no storms at all, only perpetual calm. That's the mystery, that's the beauty. Kepler-22b asks for nothing. It offers no grand drama, no explosive chaos. Instead, it exists as a meditation in space, a lesson in slowness, a lullaby wrapped in ocean mist. And maybe that's what makes it better than Earth, not because it's livelier, but because it's quieter. Time, as we understand it on Earth, is tangled up in rhythm, the rotation of the planet, the orbit around the sun, the shifting of the seasons, the pulse of days and nights that tick by like a metronome. But on Kepler 22b, that rhythm might dissolve. Its rotation speed is still unknown, but there's a real chance the planet could be in a state of tidal locking or partial locking, where one side of the planet faces its star more often or even constantly. That means a portion of Kepler 22b may exist in perpetual day, basking in soft light forever, while another side is cast into eternal night. And in between, a twilight band. Imagine living in that zone, a vast belt circling the planet where the sun never fully rises nor fully sets. It would hover near the horizon, fixed in place, smudging the sky with burnt golds and violets, casting impossibly long shadows over the open sea. You'd lose all sense of a 24-hour day. Time wouldn't pass by ticking clocks. It would stretch. Days would blur into months, months into years. Light would soften into a permanent glow. Sleep would come when your body asked for it, not when the sun dipped below a horizon you may never see. Now, imagine weather in this kind of world. Not driven by rising and falling temperatures over land and sea, but by the balance between constant warmth and lingering cold. On the sunward side, water might slowly evaporate, feeding the clouds with endless moisture. On the night side, the air would cool and condense, allowing that moisture to fall back as gentle, unbroken rains. This could create a massive planet-wide current, air flowing from the hot side to the cold, then looping back. A river of wind that circles the globe without end. And yet, due to the planet's mass and atmospheric depth, this wind might never howl. It would drift. Slow, wide, low, a continuous breeze that caresses rather than carves. Clouds here might be immense, bigger than any system on Earth. A single weather pattern could span thousands of miles, a gentle roiling blanket that moves at the pace of continents. There would be no lightning, no thunder, just distant rumbles like the echo of waves from a sea you can't see. Rainfall would be soft and unhurried. It would descend in fine mists that took hours to reach the surface. Rain that never splashes, only settles. Rain you'd feel on your face as a memory before you even noticed it falling. On the sunlit side, skies might be clearer. You'd look up and see layers of soft blue-gray streaked with muted gold. On the dark side, there might be dazzling auroras. Not green, as on Earth, but deep magentas and soft white curls, twisting slowly over the endless sea, fed by the planet's magnetic field, interacting with solar wind. And in the twilight belt, maybe the most surreal vision of all. A sky that never fully brightens or darkens, filled with colors that blend like watercolor. High-altitude clouds painted in permanent dusk, while the ocean below reflects a pale, bruised sky. You wouldn't be able to tell morning from night. It would all feel like one long sigh. For humans, adapting to this would be a quiet unraveling of expectation. No schedules, no rush. If you lived here, if humanity ever built floating habitats, airships, or ocean stations on Kepler 22b, your life would be dictated by slow cycles. You'd grow crops under diffuse sunlight that never blazed. You'd sleep whenever your body wanted, lulled by the sound of wind on waves and the rhythm of soft rain. Homes might float just beneath the cloud layer, tethered to large platforms. Solar energy could power everything, steadily harvested from the always present glow. There'd be no fuel crisis, no firewood, just endless, mild sun. Maybe not enough to suntan, but more than enough to survive. And you wouldn't just live on Kepler 22b, you'd live with it. There are no predators here, no forests to clear, no deserts to cross. The environment wouldn't push back, it wouldn't test your limits. It would invite you to slow down, to listen. Even speech might change. In a world this quiet, this calm, there'd be no need to shout, no reason to hurry. Conversations might stretch longer, with long pauses where people simply watch the clouds or trace ripples in the sea with their fingers. It's the kind of place that encourages reflection, not ambition, not conquest, just being. And while Earth pulls us forward with urgency, Kepler 22b would draw us inward. It's not just a better planet because it could support life. It's better because it lets life unfold without noise, without violence, without the constant demand to change or compete. Here, existence itself is enough. Night on Kepler-22b isn't like night on Earth. There are no crickets chirping in the trees, no rustling leaves, no headlights winding down a far-off road, just the slow inhalation of ocean and air. The kind of stillness that makes you notice your own heartbeat. If there is life here, it must be as quiet as the world that holds it. Let's imagine for a moment what could thrive in this silence. In the upper layers of the ocean, where the filtered light still has reach, photosynthetic organisms might drift like marine snow. Not plants necessarily, but plankton-like structures, delicate webs that float freely, absorbing sunlight through translucent skin. Their forms might not be green, but softly glowing, blue, silver, or faintly violet, evolved to catch the widest spectrum of dim starlight. They wouldn't need roots. No land exists to anchor them. Instead, they drift with currents, forming wide, slow-moving blooms that pulse over the surface like a living sky reflected in the sea. You might sail above one and see it shimmer beneath the waves, a pulsing mass of color, flickering faintly like fireflies under glass. And below them, in the darker waters, something stranger still. Bioluminescent creatures could fill the depths. Not aggressive predators or gaping-mouthed monsters, but subtle, elegant forms. Long, ribbon-like swimmers that trail threads of light behind them. Jellyfish analogs that pulse in slow intervals, releasing soft rings of purple or green as they float by. Thin-bodied fish with glowing organs along their sides like constellations flickering across their skin. On Earth, deep-sea creatures glow to lure prey or mates, but here, with no competition and no sun to outshine them, light becomes something gentler. A language, a lullaby, a way of saying, "I am here," to a world that rarely answers back. Some of these creatures might never break the surface. They'd live their whole lives in darkness, following faint chemical trails, or simply drifting. Others may rise only at night, clustering beneath the cloud veil, rising toward the twilight with a slow grace. You wouldn't hear them, but you might see them if you floated in the dark ocean yourself and turned off your lights. The water around you would begin to glow, just slightly, like distant stars reflected in ink. The deeper you looked, the more the lights would seem to stretch, trailing downward into a night that never ends. And you'd realize this isn't absence. This is presence, refined. If Kepler-22b has native life, it may not move quickly. It may not rush to grow, reproduce, or consume. On a planet without seasons, with stable temperatures and few threats, life could evolve for endurance, not speed. A single organism might live for centuries. It might take decades to mature, longer to reproduce. And yet it would persist, slowly, silently, gently. Imagine a creature the size of a blue whale drifting just beneath the surface, not hunting, not fleeing, just floating, gilled and ancient, with luminous lines pulsing across its sides like veins of moonlight. Its heart might beat once every 2 minutes. Its movement might take hours to span a kilometer, but it would know the ocean better than any machine. It would listen to currents, follow warmth, speak only through flashes of light. Slow, deliberate, thoughtful. It would never see a sky, but it would know the rhythm of the clouds above. Now imagine you're there on a small vessel, not a ship exactly, but a sort of floating haven. It's nighttime, or close enough. The cloud layers overhead are thick, painted with soft starlight. The air is cool, moist, still. You lean over the edge of the railing. The sea stretches infinitely in all directions, smooth and black like polished stone. Every now and then, a ripple, then a glow. You can't tell how deep the light is coming from, maybe meters, maybe miles. It flickers like an echo, then fades. You don't speak. There's no need to. Even your thoughts feel quieter here, more spaced out. You don't think in sentences anymore, more in feelings, in moods, in drifting impressions. You start to feel like you're part of the sea, as if your breath matches its rhythms, as if your presence barely disturbs the silence of this place. And you're okay with that. You look up. The stars are sharp through the breaks in the clouds, brighter than on Earth where city lights and smog blur them out. Here you see everything. And for the first time, maybe you understand what infinity means. It doesn't feel frightening. It feels still. As you drift, you wonder how many generations of quiet creatures have lived here, evolved in these waters, sent their lights into the dark, received no reply, and kept glowing anyway. Not out of desperation, but out of peace. The ecosystem of Kepler-22b isn't a contest. It's a poem, a series of soft notes played by beings who have never seen fire, never climbed trees, never built anything beyond themselves. And maybe that's what makes them beautiful. Not their intelligence, but their acceptance. The universe may be hostile, violent, cold, but here in this far-off water world, life doesn't need to fight. It just needs to float. Night on Kepler-22b isn't like night on Earth. There are no crickets chirping in the trees, no rustling leaves, no headlights winding down a far-off road, just the slow inhalation of ocean and air, the kind of stillness that makes you notice your own heartbeat. If there is life here, it must be as quiet as the world that holds it. Let's imagine for a moment what could thrive in this silence. In the upper layers of the ocean, where the filtered light still has reach, photosynthetic organisms might drift like marine snow. Not plants necessarily, but plankton-like structures, delicate webs that float freely, absorbing sunlight through translucent skin. Their forms might not be green, but softly glowing, blue, silver, or faintly violet, evolved to catch the widest spectrum of dim starlight. They wouldn't need roots. No land exists to anchor them. Instead, they drift with currents, forming wide, slow-moving blooms that pulse over the surface like a living sky reflected in the sea. You might sail above one and see it shimmer beneath the waves, a pulsing mass of color, flickering faintly like fireflies under glass. And below them, in the darker waters, something stranger still. Bioluminescent creatures could fill the depths, not aggressive predators or gaping-mouthed monsters, but subtle, elegant forms. Long, ribbon-like swimmers that trail threads of light behind them. Jellyfish analogs that pulse in slow intervals, releasing soft rings of purple or green as they float by. Thin-bodied fish with glowing organs along their sides, like constellations flickering across their skin. On Earth, deep-sea creatures glow to lure prey or mates. But here, with no competition and no sun to outshine them, light becomes something gentler. A language, a lullaby, a way of saying, "I am here," to a world that rarely answers back. Some of these creatures might never break the surface. They'd live their whole lives in darkness, following faint chemical trails or simply drifting. Others may rise only at night, clustering beneath the cloud veil, rising toward the twilight with a slow grace. You wouldn't hear them, but you might see them. If you floated in the dark ocean yourself and turned off your lights, the water around you would begin to glow, just slightly, like distant stars reflected in ink. The deeper you looked, the more the lights would seem to stretch, trailing downward into a night that never ends. And you'd realize this isn't absence. This is presence, refined. If Kepler-22b has native life, it may not move quickly. It may not rush to grow, reproduce, or consume. On a planet without seasons, with stable temperatures and few threats, life could evolve for endurance, not speed. A single organism might live for centuries. It might take decades to mature, longer to reproduce, and yet it would persist, slowly, silently, gently. Imagine a creature the size of a blue whale, drifting just beneath the surface, not hunting, not fleeing, just floating, gilled and ancient, with luminous lines pulsing across its sides like veins of moonlight. Its heart might beat once every 2 minutes. Its movement might take hours to span a kilometer, but it would know the ocean better than any machine. It would listen to currents, follow warmth, speak only through flashes of light, slow, deliberate, thoughtful. It would never see a sky, but it would know the rhythm of the clouds above. Now imagine you're there on a small vessel, not a ship exactly, but a sort of floating haven. It's nighttime, or close enough. The cloud layers overhead are thick, painted with soft starlight. The air is cool, moist, still. You lean over the edge of the railing. The sea stretches infinitely in all directions, smooth and black like polished stone. Every now and then, a ripple, then a glow. You can't tell how deep the light is coming from. Maybe meters, maybe miles. It flickers like an echo, then fades. You don't speak. There's no need to. Even your thoughts feel quieter here, more spaced out. You don't think in sentences anymore, more in feelings, in moods, in drifting impressions. You start to feel like you're part of the sea, as if your breath matches its rhythms, as if your presence barely disturbs the silence of this place. And you're okay with that. You look up. The stars are sharp through the breaks in the clouds, brighter than on Earth where city lights and smog blur them out. Here you see everything. And for the first time, maybe you understand what infinity means. It doesn't feel frightening. It feels still. As you drift, you wonder how many generations of quiet creatures have lived here, evolved in these waters, sent their lights into the dark, received no reply, and kept glowing anyway, not out of desperation, but out of peace. The ecosystem of Kepler-22b isn't a contest. It's a poem, a series of soft notes played by beings who have never seen fire, never climbed trees, never built anything beyond themselves. And maybe that's what makes them beautiful. Not their intelligence, but their acceptance. The universe may be hostile, violent, cold, but here, in this far-off water world, life doesn't need to fight, it just needs to float. Gliese 581G is a world that never sleeps, but also never wakes. It lives forever in twilight, caught between night and day. One side of the planet bakes under endless sunlight, the other is cloaked in an eternal, starless night. But between those extremes, along the slender edge of its horizon, lies a belt of eternal dusk, a soft golden glow stretching around the entire planet. This is the Twilight Zone, and it might be perfect. This isn't some science fiction concept. Gliese 581G, a planet orbiting the red dwarf star Gliese 581, is real. It's about 20 light-years from Earth. Not exactly close, but near enough that it's been studied closely since its discovery. It sparked enormous excitement when scientists realized this planet might be in the habitable zone. Not too hot, not too cold, just still. Tidal locking is the key here. Because Gliese 581G is so close to its star, it likely rotates once for every time it orbits, meaning one side of the planet always faces its sun and the other never does. But while that may sound hostile, the in-between, the edge, the rim, the terminator line, could be the Goldilocks zone, a place where heat from the day side mixes gently with cool air from the night, a place where temperatures stabilize, where winds, while constant, are slow and rhythmic, where light isn't harsh but warm and amber-hued, like an endless golden hour. Imagine waking up to that kind of light every day, a planet where the shadows never move. Time wouldn't feel the same here. With no rising or setting sun, you'd measure your days by your heartbeat, not your watch. Maybe you'd use the wind as your clock, a slow, reliable breeze that tells you how long you've been awake. Or you'd simply stop counting, because what's the point of minutes when every hour feels the same? Life on Gliese 581G might reflect that stillness. Even if we never find native life here, we can imagine what it would be like to be alive on this world, to feel its rhythm, to build a life not shaped by alarm clocks or rush hours, but by the balance of warmth and shadow. It's not the drama of Earth's changing seasons or stormy oceans. It's gentler, more meditative. This planet wouldn't reward speed. It would reward patience. Growth might be slow. Crops that take months to mature, flowers that bloom only once every few years. You'd get used to waiting, and in doing so, you might start noticing things again. The way the wind hums through cables, the way condensation forms on solar panels overnight, or how the stars shift ever so slight on the dark side each decade. And speaking of stars, the night side of Gliese 581G would be breathtaking. With no atmosphere to scatter light or pollution to dim the view, the sky would be so full of stars that darkness would feel alive. Entire galaxies would be visible to the naked eye. You might walk to the edge of your settlement just to look out at that celestial curtain, endless, detailed, and whispering of everything beyond. And then, just behind you, the warm, unwavering glow of the red sun. A sun that never moves. There's a spiritual calm that comes from permanence. Earth teaches us to adapt, to move quickly, to dodge storms, to follow seasons, to chase the sun. But Gliese 581G offers something else entirely. A stillness that asks you to stop chasing, to stay, to breathe, to be. And for some of us, especially those tired of the noise, that might be better than anything Earth can offer. The air on Gliese 581G would feel different, not the heavy, humid air of Earth's tropical zones, not the dry, thin atmosphere of a desert, but something more balanced, a breathable composition that could support life, a slight chill with an almost imperceptible warmth mixed with a steady, soft wind. It's the kind of environment where you don't need to rush to find shelter from the heat. nor do you have to layer up against the cold. Instead, you simply exist in harmony with the world around you. Imagine walking along the twilight zone of the planet, where the light is never harsh, but always in flux, a permanent golden hour that stretches into the distance. The air would be thick with moisture, but not oppressive. You would feel it as a soft pressure on your skin, like a gentle hug that keeps you grounded. The kind of atmosphere where your breath comes easy and the stillness allows for an almost meditative state of existence. The planet's atmosphere, like Earth's, is mostly composed of nitrogen and oxygen. But because of the planet's tidal locking, where one side faces the sun permanently while the other side is plunged into eternal darkness, the air would be a delicate balance. Winds would flow constantly from the sunlit side, cooling as they reach the twilight zone, mixing with the cooler air from the dark side. These winds would carry the scent of the planet's vegetation and possibly even the subtle fragrance of alien life. The surface temperature would be remarkably stable in this twilight zone, neither scorching hot nor freezing cold. During the day, the warmth from the sun would filter through the atmosphere, providing a gentle heat, while at night, the temperature would drop only slightly. It's the kind of warmth that lets plants grow, life thrive, and human settlements flourish in the eternal evening. Speaking of plants, imagine the alien vegetation here. Life on Gliese 581G would need to adapt to these perpetual twilight conditions. Photosynthesis, if it occurs, would be different from what we know. On Earth, plants use sunlight to convert carbon dioxide into energy. Here, with the soft glow of the red dwarf star, plants might be adapted to soak in not just sunlight, but also the faint infrared light that filters through the atmosphere. Perhaps they've evolved to be darker in color, absorbing every bit of light available and thriving in the weak but consistent illumination that surrounds the twilight zone. You wouldn't find towering trees like those on Earth. Instead, you might encounter low-growing vegetation that spreads wide across the land. Small, ground-hugging plants with vast, absorbent leaves stretching out in all directions would cover the planet's surface, soaking in as much light as they can. These plants wouldn't need to grow high. They simply need to spread far, absorbing every photon of sunlight, even the ones scattered faintly by the atmosphere. The atmosphere on Gliese 581G would be rich in colors that would feel entirely foreign to us. There might be hues of red, purple, and orange in the sky, caused by the light filtering through the atmosphere in a way that gives the air an ethereal glow. The surface would reflect that, casting everything in a soft, golden hue, light that feels warm, yet never burning. Now imagine what it would be like to step outside in the early evening, to walk through this alien twilight. The atmosphere would be full of quiet sounds, perhaps the faintest hum of the wind rustling the leaves, or the distant echoes of alien creatures calling out in the distance. The air would feel fresh, almost metallic, like ozone just before a thunderstorm. But here there's no storm, just that perfect, steady rhythm of wind and calm. Without the disruptions of rapid weather changes, Gliese 581G's environment could create a unique and peaceful existence. No violent storms to worry about. No unpredictable climate patterns that ruin harvests or flood settlements. Instead, the wind would change slowly over the course of months, perhaps even years, shifting just enough to remind you that time does pass. You would never feel rushed. The life here would need to adapt to this unchanging pace, perhaps by living slow and steady. Animals, if any exist, would likely move at a relaxed pace, following the rhythm of the planet's quiet atmosphere. They might be small and agile, creatures designed for endurance rather than speed. They would live in harmony with the slow-moving winds and steady temperatures, evolving in ways that are subtle and long-lasting. As humans, we might struggle to adapt at first, but in time, we could learn to embrace the peace. This kind of life would demand patience, yes, but it would also allow us to thrive in new ways. We'd learn to coexist with this world, moving slowly, thinking deeply, and breathing with the planet's gentle rhythms. What would it feel like to wake up every day in twilight? Gliese 581G, with its serene, unhurried existence, offers the perfect opportunity for humanity to reassess how we live. In a world where the pace of life is set by the slow-moving winds and the delicate balance of light, our daily lives would become rooted in the cycles of the planet. not the artificial rhythms of clocks and calendars. The first settlements on Gliese 581G would likely be simple. Human colonization wouldn't rush in with grand cities or sprawling metropolises. Instead, settlers would start with small, efficient communities, built not just to survive, but to blend with the environment. The goal wouldn't be to impose on the world, but to create something in harmony with its gentle, eternal evening. These settlements would likely be compact, using sustainable materials, lightweight, renewable, and adaptable. Think of structures designed to capture energy from the planet's weak but constant sunlight. Solar panels would be efficient and abundant, powered by both the red dwarf star's light and the soft reflection of the twilight zone. The buildings themselves might be crafted from biotechnological materials that adapt to the environment, growing stronger over time, just like the plants around them. The architecture would be low-slung, sprawling, and organic, much like the landscape. Buildings wouldn't stand tall, but would spread out across the twilight zone, nestling into the soft ground. Walls might be made of biofabricated materials, and roofs could be covered with greenery, blending seamlessly with the planet's ever-shifting palette of colors. The idea is to be a part of the environment, not separate from it. In such a world, technology would also evolve slowly, designed not to interfere with the gentle rhythms of Gliese 581G, but to enhance them. Transportation would be quiet and efficient, perhaps powered by magnetic levitation or wind. Speed would be an afterthought. Instead, the focus would be on efficiency and sustainability. The movement of people would be a slow and deliberate process, mirroring the way the planet moves through its eternal twilight. Life would be intimate on Gliese 581G. Because the planet is so far removed from Earth's chaotic pace, social structures might shift. People wouldn't be racing to meet deadlines or achieve fleeting goals. Instead, the focus would be on sustaining meaningful connections and nurturing relationships. Conversations would be long, stretching across days or weeks. Without the constant buzz of distraction, humans would have more time to reflect, to engage in deep discussions about philosophy, art, and the mysteries of the universe. Without clocks ticking in the background, we might become more attuned to the rhythms of our bodies, our thoughts, and each other. Living in constant twilight would reshape our concept of time itself. Earth's bustling cities and crowded streets are always dictated by the movement of the sun, the pressure of deadlines, and the ticking of clocks. But on Gliese 581G, time would be elastic. Days would blur into one another. The passage of hours would be marked only by the subtle changes in light, the shifting of winds, or the occasional quiet sound of something small and unnoticed in the distance. People might stop using minutes and hours altogether. Instead, life could be divided into cycles. The time it takes to grow a crop, the length of a conversation, or even the time it takes for a storm to pass across the dark side of the planet. Clocks might be abandoned, with the new rhythm of life guided instead by the cycles of the planet itself. The transition from Earth's urgency to Gliese 581G's slow-moving calm would take time. It wouldn't be easy. For generations, settlers might find themselves caught between two worlds, the fast-paced demands of Earth and the serene, unhurried life of Gliese 581G. But over time, the pace would become natural. People would start to adapt, finding joy in the quiet and learning how to be present with one another. The concept of work would also change. Without the drive to produce quickly or build large-scale industries, labor on Gliese 581G would likely focus on sustainability and mindfulness. People would spend their days cultivating, maintaining, and improving their environments. Work would be something you do not because it's required, but because it's part of the rhythm of life. It might feel more like a form of cooperation with nature rather than a struggle against it. And perhaps, in time, people would learn to see productivity differently. On Earth, we're conditioned to measure success by how much we produce, how fast we can move, and how many tasks we can tick off in a day. But on Gliese 581G, success might be measured by harmony, by how well you integrate into the ecosystem, by how much peace you've created, or by how deeply you've connected with others. Perhaps there's a deeper lesson to be learned here, in the heart of the twilight. The planet doesn't rush, it simply exists, and through that existence, it allows us to do the same. It's a quiet invitation to slow down, to breathe, to let go of the artificial pressures that we've carried with us from Earth. The ecosystems of Gliese 581g would be delicate, yet surprisingly resilient. The planet's long-term viability for sustaining human life depends on its ability to maintain balance, not just for the settlers, but for any existing life forms. The constant twilight would create an environment that encourages growth, but also demands careful attention. In time, humans would need to learn how to interact with the planet's ecosystems in ways that don't disrupt the peaceful equilibrium already present. The rich, soft light that spills across the twilight zone would fuel a slow yet steady cycle of life. This twilight environment, where the glow from the red dwarf star bathes everything in a gentle amber hue, would create a unique kind of flora and fauna. Plants would evolve to be far more efficient in their use of light than those on Earth. Their need for energy would be less than what we're used to, relying on the faint light filtering through the atmosphere rather than direct sunlight. These plants would grow slowly, filling the landscape with low-lying greenery, likely covering large areas in dense clusters. Their growth would take its time, never racing against the clock, but slowly pushing out roots into the soft, fertile soil. These plants would also be able to adapt to the unique conditions of Gliese 581g. The winds, carrying warm air from the sunlit side and cool air from the dark side, would create conditions perfect for a variety of life to thrive, but only in the twilight zone. The delicate balance of temperature and humidity would allow for slow-moving, sustainable ecosystems without the sudden shocks that we might see on Earth. Because the planet is relatively small, we could also expect that life would stay concentrated around the twilight band, limiting the spread of invasive species or uncontrolled growth. Beneath the surface of Gliese 581g, life could thrive in another way. While the surface would be a world of gentle, slow-growing plants, the underground could be a bustling ecosystem, not just for microorganisms, but for larger forms of life as well. The cooler, stable temperature underground would offer shelter for all kinds of creatures, providing a habitat free from the extremes of surface conditions. Yet, these ecosystems wouldn't be entirely untouched. In fact, human colonization would inevitably create a shift in the natural rhythms of Gliese 581g. As settlers begin to build and establish settlements, the land would be altered. Trees, plants, and animals, while perhaps not as numerous as on Earth, would need to adapt to the changes. But unlike Earth, where development often brings destruction, the slow, deliberate pace of life on Gliese 581g would allow for a different kind of evolution. The introduction of human culture and technology would slowly weave itself into the fabric of the planet's natural systems. This could take many forms. For example, settlers might adopt farming practices that encourage slow, regenerative growth. In a world where life is not dictated by urgency, farming could evolve into something sustainable and restorative. Crops wouldn't be harvested quickly, but in cycles that mirror the gentle, unhurried pace of the planet itself. Likewise, animal husbandry on Gliese 581g would likely be slow and cooperative, rather than exploitative. Humans would work in partnership with the land, allowing nature to guide the process, rather than forcing it. Over generations, a deep respect for the planet's cycles would become ingrained in the settlers' culture. The work of the community wouldn't be to dominate the land, but to live alongside it, understanding the balance that exists between the twilight and the eternal night and day. It's easy to imagine that this would have a significant effect on the settlers' philosophy. Without the need to constantly push forward or race against time, the people of Gliese 581g would develop a deep understanding of patience and restraint. Progress would be measured not in leaps, but in small, deliberate steps. The settlers would learn the value of persistence, but also of stillness. Perhaps one of the most profound changes would be the settlers' relationship to technology. On Earth, technology often represents progress, but it also contributes to the rapid pace of life. However, on Gliese 581g, technology might evolve differently. Instead of creating devices that push human society toward ever faster speeds, technology here would focus on facilitating harmony. Machines would not be built to move faster or do more, but to enhance the balance of life. Solar collectors would capture just enough energy to keep settlements thriving without excess. Drones and automated systems might work the land slowly, taking care not to harm the planet's ecosystems. Transportation would not prioritize speed, but comfort, ensuring that those who travel experience the slow, meditative beauty of the twilight zone. The careful, deliberate pace of life on Gliese 581G would inspire settlers to approach every facet of life differently. Education might not follow the fast pace of Earth's schools. Instead, it might focus on cultivating a deep understanding of nature, philosophy, and the intricacies of the universe. Children might spend long hours exploring the forests, learning about the delicate ecosystems around them. Art and music would take on a more reflective quality, as settlers find new ways to express their connection to the planet. Ultimately, the peaceful rhythms of Gliese 581G would shape a culture centered on balance, respect, and mindfulness. The settlers, adapting to the unhurried pace of the planet, would learn to live in harmony with their environment, rather than trying to dominate it. Over time, this would foster a deep connection between people and the world around them, a bond that would be as permanent as the twilight that surrounds them. As we step back and reflect on the long-term possibilities for humanity on Gliese 581G, we find ourselves contemplating not just the practical aspects of survival, but the existential implications of living in a world where time moves at a slower pace and light is always gentle. The most immediate thought that arises is the planet's potential for long-term sustainability. On Earth, our rapid growth and industrialization have often come at the cost of our environment. Resources are exploited at an unsustainable rate, and ecosystems are often disrupted by the aggressive push for progress. But on Gliese 581G, the situation could be fundamentally different. The planet's natural rhythms would encourage a different kind of growth, one rooted in sustainability, balance, and patience. With its stable, unhurried conditions, Gliese 581G offers the possibility of a society that doesn't need to race against the clock, constantly struggling to produce more, faster, or better. There's no rush here. Instead, the settlers would learn to work with the land, to use its resources gently, and to make decisions with long-term consequences in mind. The concept of time would shift entirely. Without the pressure of constant deadlines, settlers would approach life with a more deliberate sense of purpose, allowing each day to unfold with intention rather than urgency. This slower pace of life could also lead to profound philosophical changes. In a world where everything isn't a race, settlers would have the opportunity to explore questions of existence, purpose, and meaning in ways that might be more difficult on Earth, where the hustle and bustle of daily life often drowns out deeper contemplation. On Gliese 581G, the quiet, the calm, and the stability of the environment would open up space for introspection. Life could become an ongoing exploration, not just of the world around them, but of themselves. In this serene twilight world, humans might come to realize that the pursuit of progress is not the ultimate goal. Instead, it's the pursuit of understanding, the pursuit of connection with each other, with the planet, and with the vast cosmos beyond. The planet's inhabitants might look to the stars above and wonder not just about what's out there, but about their place in it all. Life would become less about achievements and more about experience, connection, and the ongoing search for meaning in a universe that is vast, mysterious, and sometimes unknowable. However, on Gliese 581G, technology might evolve differently. Instead of creating devices that push human society toward ever faster speeds, technology here would focus on facilitating harmony. Machines would not be built to move faster or do more, but to enhance the balance of life. Solar collectors would capture just enough energy to keep settlements thriving without excess. Drones and automated systems might work the land slowly, taking care not to harm the planet's ecosystems. Transportation would not prioritize speed, but comfort, ensuring that those who travel experience the slow, meditative beauty of the twilight zone. The careful, deliberate pace of life on Gliese 581G would inspire settlers to approach every facet of life differently. Education might not follow the fast pace of Earth's schools. Instead, it might focus on cultivating a deep understanding of nature, philosophy, and the intricacies of the universe. Children might spend long hours exploring the forests, learning about the delicate ecosystems around them. Art and music would take on a more reflective quality, as settlers find new ways to express their connection to the planet. Ultimately, the peaceful rhythms of Gliese 581G would shape a culture centered on balance, respect, and mindfulness. The settlers, adapting to the unhurried pace of the planet, would learn to live in harmony with their environment, rather than trying to dominate it. Over time, this would foster a deep connection between people and the world around them, a bond that would be as permanent as the twilight that surrounds them. As we step back and reflect on the long-term possibilities for humanity on Gliese 581G, we find ourselves contemplating not just the practical aspects of survival, but the deeper existential implications of living in a world where time moves at a slower pace and light is always gentle. The most immediate thought that arises is the planet's potential for long-term sustainability. On Earth, our rapid industrialization have often come at the cost of our environment. Resources are exploited at an unsustainable rate, and ecosystems are often disrupted by the aggressive push for progress. But on Gliese 581G, the situation could be fundamentally different. The planet's natural rhythms would encourage a different kind of growth, one rooted in sustainability, balance, and patience. With its stable, unhurried conditions, Gliese 581G offers the possibility of a society that doesn't need to race against the clock, constantly struggling to produce more, faster, or better. There's no rush here. Instead, the settlers would learn to work with the land, to use its resources gently, and to make decisions with long-term consequences in mind. The concept of time would shift entirely. Without the pressure of constant deadlines, settlers would approach life with a more deliberate sense of purpose, allowing each day to unfold with intention rather than urgency. This slower pace of life could also lead to profound philosophical changes. In a world where everything isn't a race, settlers would have the opportunity to explore questions of existence, purpose, and meaning in ways that might be more difficult on Earth, where the hustle and bustle of daily life often drowns out deeper contemplation. On Gliese 581G, the quiet, the calm, and the stability of the environment would open up space for introspection. Life could become an ongoing exploration, not just of the world around them, but of themselves. In this serene, twilight world, humans might come to realize that the pursuit of progress is not the ultimate goal. Instead, it's the pursuit of understanding, the pursuit of connection with each other, with the planet, and with the vast cosmos beyond. The planet's inhabitants might look to the stars above and wonder not just about what's out there, but about their place in it all. Life would become less about achievements and more about experience, connection, and the ongoing search for meaning in a universe that is vast, mysterious, and sometimes unknowable. Such a shift in perspective would affect more than just individual lives. The society on Gliese 581G could evolve into one that places high value on art, culture, and shared experiences. Music, philosophy, and literature would be born out of this deep connection to the world. Artists might find new ways to capture the essence of twilight, its soft light, its ever-changing colors, and its quiet beauty. Settlers would be able to express their thoughts and feelings in ways that are not driven by urgency, but by an almost timeless sense of creativity. The experience of living on Gliese 581G would be an immersion in the natural world. Without the distractions of modern technology and the constant noise of Earth's fast-paced society, humans would become more attuned to the subtleties of their surroundings. The movement of the wind, the shift in temperature, the sounds of the distant wildlife, all of these things would become sources of deep fascination and appreciation. This connection to the planet would also foster a sense of responsibility. Life on Gliese 581G would be fragile, and humans would need to take great care to protect the delicate balance of the ecosystem. There would be no room for exploitation or waste. Instead, settlers would work alongside the natural systems, ensuring that their presence doesn't disrupt the peaceful rhythms that allow the planet to thrive. In many ways, humanity's role on Gliese 581G might be to serve as caretakers, preserving and nurturing the world that allows them to live in harmony with it. Perhaps the most profound realization that settlers on Gliese 581G would have is that the planet itself is a mirror for our own inner worlds. The constant twilight, the gentle rhythms, the slow pace of life, all of it would encourage reflection, introspection, and a deeper understanding of what it means to be human. The world would serve as a canvas for self-exploration, allowing settlers to become more fully aware of who they are and how they fit into the greater tapestry of the universe. On Gliese 581G, the sky would never be quite dark, and it would never be too bright. It would be a place where life can unfold in quiet, unhurried ways. In such a world, there would be no need to hurry, no need to worry about what's next. There would be only the present, a never-ending, peaceful now, bathed in the soft glow of the planet's twilight. The future on Gliese 581G would be uncertain, as all futures are. But one thing would be clear. It would be a future that's shaped by patience, balance, and the quiet rhythms of a world that has time to wait. Kepler 442b stands as a beacon of possibility, with its Earth-like qualities and potential to harbor life. The settlers who step onto its surface will encounter not only an alien world, but also a new way of being, one that intertwines humanity's survival with the natural environment. This new beginning offers an opportunity to build a civilization free from many of the pressures that plagued Earth. Yet, the challenges of settling on such a distant world are not to be. Technology will continue to play a critical role in the settlers' lives, but it will not be the driving force of their civilization. Instead, technology will be used as a tool to support their relationship with the planet, helping to maintain sustainability and balance. Human ingenuity will be guided by a new philosophy, one that places a premium on the well-being of the planet and its ecosystems. The settlers will recognize that their survival depends not just on their ability to adapt, but on their ability to live in harmony with the world around them. In time, as the colony on Kepler 442b grows, its society will become a model for future human settlements on other planets. The lessons learned here about sustainability, cooperation, and respect for the environment will serve as the foundation for humanity's future in the stars. Kepler 442b, with its lush landscapes, stable climate, and potential for abundant resources, will be the proving ground for a new chapter in the human story. The first generations of settlers will leave a legacy, not just of survival, but of a new way of living. They will demonstrate that it is possible to build a civilization that does not repeat the mistakes of the past, one that is rooted in respect for the natural world and for the delicate balance of life. As humanity continues its journey through the cosmos, the example set by the people of Kepler 442b will serve as a reminder that our future is not just about reaching the stars, but about learning to live in harmony with the worlds we discover. Proxima Centauri b, located in the habitable zone of the closest star to our Sun, presents a fascinating possibility. As Earth's neighbor in the vastness of space, this planet offers a glimpse into what life might be like in a more challenging, yet still intriguing environment. Despite its similarities to Earth, Proxima Centauri b comes with its own set of mysteries that make it a compelling subject for human exploration. Proxima Centauri b orbits its host star, Proxima Centauri, a red dwarf located just over 4 light-years from Earth. While the proximity to the star suggests a higher likelihood of atmospheric conditions that could support liquid water, the planet also faces unique challenges. Red dwarfs like Proxima Centauri emit intense radiation, and the proximity of Proxima Centauri b to its star suggests that the planet could be tidally locked, meaning one side always faces the star while the other remains in perpetual darkness. This tidally locked nature means that one half of Proxima Centauri b could be bathed in constant daylight, while the other side would be frozen in eternal night. The day side could experience extreme temperatures due to constant exposure to the star's rays, potentially making it too hot for most forms of life. On the other hand, the night side would be cold, with temperatures plunging to frigid levels. However, the twilight zone, the region between the day and night sides, where temperatures may be more moderate, could harbor a habitable environment. Here, life could survive in the mild conditions, provided that water and essential resources exist. The question of Proxima Centauri b's atmosphere is critical to its potential to support life. It is believed that the planet could have a thick atmosphere, possibly rich in carbon dioxide, which could trap heat and regulate temperatures across the surface. However, if the planet's atmosphere is too thin or volatile, the conditions could be far too hostile for any form of life, as seen on Venus, which also lies within its star's habitable zone but experiences extreme heat due to a runaway greenhouse effect. Assuming Proxima Centauri b can maintain a stable atmosphere and water exists in liquid form, the planet could still support a wide range of life forms, perhaps more resilient and adaptable to the extremes than anything found on Earth. The twilight zone would be the most likely place for these ecosystems to develop. Imagine vast forests with trees and plants evolved to withstand intense solar radiation, perhaps with leaves that shimmer with protective coatings, much like some earth plants in arid or high-altitude regions. These ecosystems would rely on the faint warmth and energy that trickles into the twilight zone, enough to fuel photosynthesis, but not so intense as to scorch the plants. The wildlife in these zones would have to be equally adaptable, possibly developing unique evolutionary traits to survive in an environment with extreme variations between light and dark, heat and cold. Creatures in the twilight zone may develop extraordinary adaptations, such as reflective skin to protect them from the star's radiation, or enhanced night vision to see in the perpetual darkness. Evolution on Proxima Centauri b could lead to species that are fundamentally different from anything Earth has known, shaped by the harsh and unique environment in which they evolve. However, the true potential of Proxima Centauri b lies in its ability to sustain a self-contained ecosystem in this twilight zone. If the planet's ecosystem is healthy, there could be a rich web of life in the narrow band of habitable conditions between extreme environments. Plants would thrive, providing food for herbivores, while predators would hunt the plentiful life forms. The entire system would be intricately linked, with each species playing a part in maintaining the balance. The energy required to sustain life in this zone would likely come from the planet's faint star and any geothermal activity beneath the surface, which could provide warmth and essential nutrients. For humanity, settling on Proxima Centauri b would present significant challenges. While the planet is close enough to Earth to make the journey feasible with future technology, the environmental conditions would require immense adaptation. Human settlers would need to design habitats capable of surviving in extreme heat and cold, possibly relying on advanced climate control systems to regulate their living spaces. The planet's constant radiation exposure would also require effective shielding, and any technological systems would need to be resistant to the wear and tear caused by the harsh stellar environment. Life on Proxima Centauri b would not be easy. The planet's unique conditions would mean that settlers must live in balance with the environment, carefully managing resources to ensure sustainability. Agriculture would likely be limited to the twilight zone, where conditions are most conducive to farming. However, this region could be rich in potential, providing settlers with a sustainable source of food, water, and other resources. The planet's geothermal activity could also offer additional energy resources, reducing reliance on solar power. Proxima Centauri b may not be as hospitable as other planets like Kepler 442b, but it presents an exciting challenge for humanity. If settlers can learn to adapt to the planet's extremes, they could create a thriving, self-sustaining colony in the twilight zone. Over time, humanity could learn to not only survive but thrive on Proxima Centauri b, building a civilization that balances technology, nature, and the unique demands of their new home. As settlers begin to carve out their existence in the twilight zone of Proxima Centauri b, their daily life will revolve around managing their environment and building infrastructure that can withstand the extremes of the planet. The key to survival on Proxima Centauri b will be adaptability, as the settlers will have to continuously find innovative ways to coexist with the planet's unusual conditions. The resources that Proxima Centauri b offers would be essential for sustaining life. Mining operations would need to extract minerals from the surface and possibly the underground, where conditions might be less hostile. Settlers would likely have to mine for metals such as iron, nickel, and copper, which could be used for building materials and technology. Furthermore, the planet's geothermal activity might provide a source of energy, tapping into the planet's inner heat to power colonies, especially on the cooler night side. Harnessing this geothermal energy could create a network of self-sustaining systems that would help the settlers rely less on external energy sources. Building homes and settlements would be an intricate task. Structures would need to be designed with insulation in mind, ensuring that they can endure both the harsh sunlight on one side of the planet and the extreme cold on the other. Habitats would likely be placed in the twilight zone, where temperature fluctuations are more moderate. These homes would need to be constructed with advanced materials capable of reflecting or absorbing radiation while maintaining internal warmth. A combination of advanced architecture and technology would enable settlers to create safe havens amidst the alien landscape. Farming on Proxima Centauri b would require significant research and experimentation. Crops would need to be engineered to survive in the planet's dim, variable sunlight and harsh conditions. These crops might be genetically modified to withstand radiation and to grow in the planet's unique soil conditions. Advanced farming techniques such as vertical farming, hydroponics, and closed-loop ecosystems would be essential to creating a sustainable food supply. The settlers would have to learn how to efficiently utilize the resources available in their environment, using minimal water and energy to produce food for the growing population. For food security, settlers would also likely depend on animal husbandry, particularly for protein sources. The harsh conditions could lead to the development of unique breeds of livestock, possibly even genetically engineered to thrive in the twilight zone's peculiar environment. These animals might be more resilient to radiation, with adapted internal systems capable of surviving prolonged exposure to the sun's intense radiation on the day side. The settlers would have to create an environment for these animals that protects them from radiation while allowing them to flourish. While Proxima Centauri b may not offer the same immediate abundance as Earth, it offers humanity a chance to develop advanced technologies that could be useful for other planetary colonization efforts. The planet's unique features would push settlers to explore new ways of life that prioritize sustainability and balance with the environment. Innovations born on Proxima Centauri b could redefine the future of space colonization, offering new solutions for humanity's survival and expansion in the stars. As time passes, a new culture would emerge on Proxima Centauri b. The settlers would adopt new ways of thinking about their place in the universe, influenced by the alien nature of their environment. They would forge a new identity, one that combines the creativity and resilience of humanity with the challenges posed by their new world. Over generations, the settlers would grow more accustomed to their surroundings, with families and communities becoming deeply connected to the planet. Cultural practices would likely center around sustainability and environmental harmony. Given the challenges of living on Proxima Centauri b, there would be an emphasis on cooperation and working together to ensure the survival of the colony. Every resource would be precious, and careful consideration would be given to how each individual interacts with the ecosystem. This philosophy of balance and respect for nature would be woven into every aspect of life, from daily routines to larger social systems. Religious and philosophical beliefs might evolve around the unique characteristics of the planet. The constant cycles of day and night, the juxtaposition of intense heat and freezing cold, could shape spiritual views that focus on duality, balance, and the power of adaptation. Ancient Earth religions could give way to new belief systems that reflect the settlers' understanding of the universe and their place within it. As the colony on Proxima Centauri b thrives, it could serve as a model for future human settlements on other planets. The lessons learned from adapting to such an extreme environment could provide valuable insights for overcoming the challenges posed by other exoplanets. Proxima Centauri b, with its unique combination of extremes, offers a chance for humanity to learn not only about survival, but also about the deeper interconnectedness of life in the universe. Though far from Earth, Proxima Centauri b could be humanity's first step in establishing a lasting presence beyond our home planet. It offers the opportunity to explore the mysteries of the universe, to push the boundaries of what is possible, and to create a thriving civilization in a place that, for now, is purely theoretical. Proxima Centauri b's potential to support life and its proximity to Earth make it a prime candidate for humanity's next great adventure in the cosmos. As Proxima Centauri B's settlers establish their colony, they'll find themselves in a constant cycle of innovation and adaptation. The planet's unique features would demand constant research into improving living conditions, managing resources, and developing new technologies to ensure the survival of future generations. One area that would require significant development is the planet's communication systems. Given Proxima Centauri B's distance from Earth, direct communication would experience a delay of several years due to the vast distance between the two worlds. This means that settlers would not have the same instant connection to Earth as people on Earth currently do. As a result, a strong sense of independence and self-reliance would develop within the colony. New forms of communication and governance would have to emerge, focusing on collaboration among settlers rather than reliance on distant authorities. The cultural evolution of Proxima Centauri B would also be shaped by this isolation. Over time, settlers might develop unique languages, customs, and traditions that reflect their new way of life on this distant world. The constant exposure to the extreme environment would lead to the development of a new identity, one that is intimately tied to the harsh yet beautiful world of Proxima Centauri B. Festivals, rituals, and other cultural expressions would revolve around the planet's unique characteristics: the eternal struggle to survive, the ever-present need to adapt, and the profound connection to the land that sustains them. As the settlers grow accustomed to the rhythm of life on Proxima Centauri B, they would become increasingly self-sufficient. Agriculture, energy production, and even local governance would be handled within the colony, reducing reliance on Earth-based resources. Over time, settlers would learn to create closed-loop ecosystems where waste is recycled and resources are carefully managed to ensure the sustainability of the colony. In this way, Proxima Centauri B would become a model for future human colonization efforts, demonstrating the potential for humanity to thrive in even the most extreme environments. In terms of energy generation, Proxima Centauri B's settlers would likely rely on a combination of solar power and geothermal energy. The constant exposure to the star's radiation would provide opportunities for solar energy harvesting, while the planet's geothermal activity could supply an additional stable source of power. Settlers would have to design their homes and infrastructure to take full advantage of these energy sources, ensuring that the colony remains powered even during periods of darkness. Although Proxima Centauri B's climate and conditions present many challenges, the planet's potential for hosting life, both terrestrial and extraterrestrial, makes it an intriguing candidate for future human exploration. If the settlers can overcome the planet's extreme conditions, they could create a thriving colony that not only survives, but flourishes. The settlement could become a beacon of human achievement, a testament to the resilience and adaptability of humanity in the face of the unknown. Moreover, Proxima Centauri B could serve as a stepping stone for future human exploration of the stars. The knowledge gained from colonizing this challenging planet could provide valuable insights into how to survive and thrive on other distant exoplanets. The lessons learned here could inform the design of future space missions, from spacecraft engineering to habitat construction, and may one day lead to humanity's expansion into the broader cosmos. The journey to Proxima Centauri B is far from simple, but the potential rewards are immeasurable. This distant world, bathed in the light of a small red dwarf star, represents both the challenges and the promise of humanity's future in the stars. If settlers can learn to adapt and thrive in such an alien environment, Proxima Centauri B could mark the first step in a much larger journey, one that will carry humanity into the far reaches of the galaxy.